In this video, you're going to learn how to create a chatbot that answers questions based on custom knowledge base. And you're going to do that using an open large language model, an open embedding model, LangChain, and also you're going to learn how to stream the responses using just a single GPU. Hey everyone, my name is Venerin, and in this video, you're going to learn how to build a customer support chatbot using custom knowledge base. First, we're going to start with creating our own dataset that is based on Skyscanner's Help Center FAQ. Then we're going to learn how to load an open large language model right within a HuggingFace pipeline that is provided by LangChain. Then we're going to embed our documents data using Chroma DB and an open embedding model. Finally, we're going to wrap everything within a chain with memory in order to start chatting with our chatbot. We're going to demo the whole pipeline and you will see whether or not the model is actually performing quite well compared to, for example, something like ChatGPT or GPT-4. Let's get started. There is a text tutorial that is available for ML Expert Pro subscribers, and here you can already find the complete source code along with some explanations on why and how you can create your data and the model itself. So if you want to support my work, please consider subscribing to ML Expert Pro. To create the knowledge base for our chatbot, I've used the Skyscanner Help Center, and here you can go through a lot of the questions that they have for their customers. They are split into different categories, and what I did was to take about 12 questions and took the questions and the answers, and if you expand a question, you see the answer for it. So what I did was to just take the question and then the answers, and then I'm going to show you how I've prepared the text files. Of course, feel free to use your own resources as customer knowledge or custom knowledge for your chatbot, and let me know how it went in the comments down below. I have a Google Colab notebook that is already running, and here you can see that I'm using a T4 GPU. I'm going to go through the runtime type, and you see that I'm using just a GPU runtime with T4 GPU, not an additional RAM or anything like that. So you should be able to run this in Google Colab free. So the first thing that I do here is to install all of the available or all of the required libraries that we are going to use. And then these are the imports. I'm going to run those. So the first thing that I'm going to do is to take the questions from the Skyscanner help page. And in it, I am going to create a directory called Skyscanner. And within this directory, I'm going to create the files. So here I have a function called write file, and in it, I'm going to pass in the question, the answer, and then the file path. So this is the format that I'm going to use. It is going to be the text string, and it's going to start with a Q and double dot, then the question and a double dot and answer. So I'm going to write this file into the file path that is provided as an argument. And here I'm going to start by writing this directory. And after that, I'm going to insert all of the questions that we have. So in that way, I'm going to run through all of the files. And I have 12 of those. I've pretty much went and picked them on my own, so you might try some different files and you might have a look at why and how it works with different files. Let's see the directory structure after the files are complete. And here you can see that we have the 12 questions. And if you open up a single text file, you see that basically the format is kept, and we have the questions and the answers right within here. So this is pretty much how you create your data. The model that we are going to use is called Nus Hermes 13B, and it is a state-of-the-art, according at least to the authors, model that is trained on over 300,000 instructions, and it is provided to us by Nus Research. And the guys from here are essentially fine-tuning the Llama 13B model, and this should leave you a clue that this is actually not a model that is approved for commercial use. So keep that in mind when you're choosing your model. And the authors on HuggingFace have a lot of information, and this is the prompt format that you might want to use. We're going to use the same format actually right here. So they have some benchmark results, but the real reason why I chose this model in particular was actually the Chatbot Arena leaderboard. This is provided by LLM or Large Models SIS organization. And here you can see that the Nus Hermes is right here. And it is, again, not for commercial use, but it is still a 13B or 13 billion parameter model that is very high on this chart. And it is available from Auto GPTQ. So it is a quantized, there is a quantized version of this model. And at least in my evaluations, this model was performing very well compared to some of the other models. I've also tried Wizard LM and then Vicuna, and I've tried MPT-7B, and none of those were actually performing as good as the Nus Hermes. So you might want to try it for yourself, and probably you might want to try some of the other models as well. So let's continue with loading the model. First, I'm going to get the current device. In our case, this is going to be actually the GPU device or CUDA device. And then I'm going to load the model itself. Since I've already downloaded it, this is going to skip this part and just load the model from the cache. You can see that I'm passing in the complete path to the model, and I want this to use the safe tensors format. Also, I want this to trust remote code, and I want this to be loaded on the device, which is again the CUDA device. And I'm using the AutoGPTQ, which is essentially a library that allows us to load the quantized versions of those models. And then I'm also getting the generation config, which we're going to use to do the actual generation. So this is pretty much what you need to pass in order to load your model. And after this is complete, I'm going to create our sample question: which programming languages is more suitable for a beginner, Python or JavaScript? We're going to ask our large language model that, and I'm going to convert this into the following format, which is essentially the same that we saw in the HuggingFace repository. So this is the instruction: which programming languages is more suitable for a beginner, Python or JavaScript? All right, so let's run the inference in this model or with this model. And first you see that I'm passing in the prompt to the tokenizer. I want this to return PyTorch tensors, and I'm passing the input IDs that are returned from the tokenizer to the CUDA device. So I'm putting in the encoding on the CUDA device, and then I'm running the inference mode. And within it, I am running the generate method, which accepts the inputs from the tokenizer. And then I'm passing in some parameters. I want the temperature to be 0.7. We're going to change this in a bit. And then I want at most to 512 tokens. So you see that this is actually done in about 6 seconds. This will very dependent on the GPU that you have and the machine, of course. So let's see what the response has. So you see that the response actually contains the original prompt, and this is the actual response. Python is generally considered more suitable for beginners due to its readability and simplicity compared to JavaScript. And you see that we have some special tokens that start and end the sequence. And pretty much I would agree with that one, actually. Yeah, Python seems like a better language for beginners. Let me know what is your opinion down in the comments below. I'm sure that you might have another opinion. Let's see the generation config. It is pretty simple. We have beginning of sequence token, end of sequence, and padding token IDs. So pretty standard. So in order to use this large language model, we are going to create a pipeline that is from HuggingFace pipeline, and we're going to wrap this pipeline within a LangChain HuggingFace pipeline. So we're going to be able to use the pipeline right within a chain in LangChain. But first, I'm going to create this text streamer, which is going to essentially output the responses from the pipeline into our standard output. In our case, we're going to print the responses down into the notebook. And here we are doing some special parameters, we want this to skip the prompt. So this will essentially remove all of this. And then we're going to skip the special tokens, the start and the end of the sequence. And I just want to not use multiprocessing just in case. Sometimes I had trouble with the streamer if this was not set properly. And then I'm going to create a text generation pipeline. Again, this is coming from HuggingFace. We passing in the model, the tokenizer, the max length, which is essentially the max length of the model, 2048 tokens. I want the temperature to be 0, so I want this to be highly reproducible for you guys. And then we are passing in the streamer itself and then a batch size of 1. So this will create the pipeline. And it says that the WAMA GPTQ for causal language modeling is not supported for text generation. This is just a warning and it appears to be working just fine. Probably in the later versions of the Transformers library, this is going to be working much better and without a warning. And finally, I'm going to use the pipeline to create a HuggingFace pipeline in LangChain. And you can see that when I prompt the model, we are actually getting the streamer to output the result. And this is pretty much how you do the modeling or the model in here. So for the embeddings, I'm going to use this again. Let me show you the leaderboard on the embeddings. And this leaderboard is called Massive Text Embedding Benchmark, MTEB leaderboard. And here we have a lot of datasets, total languages, etc. And one of the best embeddings was this E5 base V2. So this is actually this one. Yeah, I believe it is the same. So this embedding is working quite well. It is a base variant and it works very well compared to the Warch and Excel versions of the instructor embeddings, which are other popular embeddings. And yeah, I'm going to use those one. Let me know if you have better embeddings for this use case and how your embeddings are working here. I'm going to pretty much take these embeddings just because the retrieval average is very high on these embeddings compared to the other models. So this is why I essentially picked this one. And this type of embedding is actually introduced into text embeddings by weakly supervised contrastive pre-training. And there is a link to the archive paper. I haven't delved deep into that, but again, it appears to be working quite well. And another thing about these types of embeddings is that you can use it right within the sentence transformers library. So I'm going to go through the embeddings and I'm going to pass in the device. So this will go download the model, which is 1 gigabyte, 1.1 gigabyte, and it's going to put the model on the GPU. And you see that it actually works pretty well, even though we've already have the pipeline loaded into the GPU. And if I go to the GPU at the current time, let's see. So we have about 10 gigabytes of GPU memory used, just loading the models. So we have about 5 gigabytes to use when doing inference. So next, I'm going to pass in the Skyscanner directory, and I'm going to take all of the text files here and load those into documents. And you see that we are getting 12 as a number of documents, but I'm going to chunk these since some of the answers are very long and we have the limitations of 2048 tokens. So let's get those texts split using the character text splitter. And let's see at an example text. Why does the price sometimes change? And you see that we have this page contents within the document, and then the source of the document is also available right within the document itself. So next, I'm going to embed the texts within the Chroma database that I'm going to create. So this will create an in-memory embeddings. And if you run this, you see that when we do similarity search for example, void search, you see that the first question that we get is how do I search for flights on Skyscanner, which is very good. I mean, like when we're doing the similarity search for the chain, this is going to help us a lot. So speaking of the chain, here is the conversational chain that we're going to start with, and I'll show you actually why this chain might not be the best use case for this chatbot, and I'm going to show you what I'm using instead. So let's have a look. This is the template that I'm going to use. So you're a traveling support agent that is talking to a customer, use only chat history and the following information. So I'm passing in the context, which is going to be the documents that are returned from the embedding. And then we request that the chat support agent is going to be helpful. And if it doesn't know the answer, say that you don't know. Keep your reply short, compassionate, and informative. And then I'm passing in the chat history. Also, I'm passing in the input of the new question, and then I'm asking for the response. So let's see how this works. I'm going to load this template, and I'm going to create a prompt template using the variables context right here, the question right here, and the chat history. And I'm going to pass in the template itself. So first, I'm going to create this conversation buffer memory, which is going to take or represent the chat history, and it's going to store the questions and the responses. So here are the prefixes, the input and the response, exactly the same format that we're using here for the human and the AI. And then the output from the answer is going to be answer, and the memory key is going to be chat history, which is exactly this thing right here. And I want this to return the messages. So we are going to format everything correctly. So to create the chain from all of this, I'm going to take the large language model, which is again a HuggingFace pipeline. I'm going to make this into a stuff chain. So we are not doing any summarization or anything clever as of now. And then I want to take the ChromaDB as a retriever. So it's going to act for retrieving of the documents using similarity search. I'm passing in also the memory, and I'm going to pass in the prompt template. I want the to return the source of the documents, and I want this to be variables. So let's load this chain, and let's have a look at the first question and the response from the chain. And I'm also passing in the variables flag. So you see all of the data that is passed in to the model, and you see that the context is actually provided from the similarity search. And this is the response. Skyscanner helps you find the best options for flights on a specific date or in any day in a given month or even year. Our search algorithm, etc., scans hundreds for tips on how to best search. Please visit our search tips page. Yeah, it looks quite all right. And the response is quite good. Let's see what the answer contains. So we have source documents, the chat history, the question, etc. And you go through the source documents, you see the actual documents that were referenced when the model had to create some questions and answers for the context, which is something very good. But something that is happening when you ask a second question about flight tickets, but I can't find any confirmation. Where is it? And when you run through this, you see something very interesting. So the first prompt that you're given here for the chain is given the following conversation and follow-up question, rephrase the follow-up question to be a standalone question in its original language. So for some reason, this chain is actually first rephrasing the question that you're passing in, and then you're continuing with the response and the human and the assistant, etc. It is provided as a history. This is something that I actually don't want to happen, and I didn't find an easy way to basically turn this off. And instead of that, I continued with a QA chain, but I've added a buffer memory to it. So in this case, I am passing in the memory here and loading the QA chain. This is pretty much exactly the same thing, but I'm essentially restarting the memory. And let's see what I'm doing here. I'm going to run this. And this is again verbose mode. So the first thing that I'm doing here is to create the question, then I'm manually finding the documents that are relevant, and I'm passing in the input documents from those, and then I'm also passing in the question. So you see that the response is essentially the same, but when I ask the second question, I'm doing the same thing, but the second question in here, you see that the input and the response are just added as history, and there is nothing that is doing the actual rephrasal, something that we really don't want. So you can see that this is actually returning a good response. Let's have a look. Please contact the airline or travel agent you booked with, as Skyscanner does not have access to bookings made with airlines or travel agents. So again, the response is quite good, and I am doing the correct format that I want, since this is something that I don't want to rephrase our questions. The final piece that is going to glue everything together that we've learned this far is going to be the Chatbot Class, which I'm going to show you how you can write on your own. And here it is. So I have the original template right here, and I'm creating a class called Chatbot, which essentially takes a pipeline, embeddings, then a directory that we are going to use for the data, prompt template, and then whether or not I want this to be verbose. So what this does is to create the prompt template using the template for the prompt, and then it does two things. It creates a chain, and then creates a database from our documents that we are passing in. So let's have a look at the create chain. It is pretty much the same that we had from the what QA chain. I'm creating a buffer memory right here and passing into the chain. And for the data embedding, I'm also creating the loader, essentially the same thing that we did before, loading the documents, splitting them, and then using Chroma to create the embedding database that we want. The final piece of this class is actually the built-in, or let's say magical method in Python called call, and this allows you to actually call this object that is created from this class by in the syntax sugar of a function, if you will. And here I'm just passing in the user input, and this is what we are doing here. I'm using the database to do a similarity search, and then I'm running the chain through the documents returned from here and the user question. So exactly the same thing that we did before. Next, I'm going to create this chatbot for you. And this just creates the instance. Again, creates the chain and the database. So to use this model or chatbot, we are going to enter this loop. And these are some warnings that were associated with the pipeline. And it says that I'm using this sequentially. So if you don't want to see those warnings, I'm also including this ignore of user warnings. So the loop that we're going to go through is pretty simple. I'm going to ask for input. And if the input contains bye or goodbye, I'm going to break from it. Otherwise, I'm going to ask the chatbot for the input, and then I'm going to get the result and print a new line after this is done. So in order to test this, I'm going to start with the questions that we started with. How void search works. So this is the first question that I'm going to ask. And you see that the response is stringed right here. It works quite well, actually. So after this is done, it is asking again for another question. So I'm going to ask about flight tickets, but I can't find the confirmation. Exactly the same question as before. And then I'm going to continue with another question. Yeah, this is pretty much the same that we got so far. I entered wrong email address during my flight booking. What should I do? And it says that Skyscanner is unable to help you with changing the email, and you need to reach the airline or travel agent you booked with. So yeah, it is quite helpful actually, and it works quite well. All right, so let's finish up this and let's say bye right here. And you see that the process is now complete. So this is pretty much how you're using your chatbot. So this is it for this video. We've seen how we can create a custom knowledge base and use LangChain with an open large language model and open embeddings in order to create a customer support chatbot. We've seen how we can create a pipeline from a HuggingFace model. Then we've embedded our documents using the text files that we've prepared. And finally, we've wrapped everything within a nice class called Chatbot, which is pretty easy to interact with. And you can essentially pass in your own text right within this chatbot. Also, we've seen how you can stream the responses so your users doesn't have to wait in order to get their responses as soon as the large language model is finished with a chunk or a token from your model. Let me know down in the comments below if you want to see this type of chatbot actually deployed behind an API so you can use it as a real chatbot in your production servers. And I'll probably have to look into that and create a video for that as well. Thanks for watching, guys. Please like, share, and subscribe. Also, please join the Discord that I'm going to share in the description down below. And I'll see you in the next one. Bye.